Dear students, अस्सलाम वालेकुम वरहमतुल्लाहि वबरकातुहू। जैसा कि आप जानते हैं, वी आर स्टडीइंग बेसिक concepts of organic chemistry. So far, we have studied nomenclature of organic compounds in detail, nomenclature, IUPAC system of nomenclature, and we have then studied isomerism and its types, and later on we discussed about reaction mechanisms, reaction mechanism, and it we studied what is meant by a substrate, a reagent, electrophiles, nucleophiles, and then we studied the phenomena of electron displacement effects. In those electron displacement effects we have studied so far inductive effect, inductive effect, and then we have studied electromeric effect, electromeric effect, and we have studied resonance effect, resonance effect. And today we have to study one more electron displacement effects, rather very important effect, one of the very important effects which is involved in organic chemistry, that is called as hyperconjugation effect. Hyperconjugation effect. Dear students, you know that inductive effect, which we have studied in the beginning, is of two types. One is negative inductive effect and another one is positive inductive effect. In negative inductive effect, the electrons are drawn from the carbon chain by the electronegative atom or group, while as in positive inductive effect, the electrons are given to the carbon chain. And you know the order which is followed in positive inductive effect is like that: CH3 whole thrice C. It is more positive, it is having more positive inductive effect than this alkyl group CH3 whole twice CH. The first one is tertiary butyl group, this one is isopropyl group, and this group has more effect than CH3 CH2 group, that's ethyl group, and this is followed by CH3 group. So this is the order of plus I effect, plus I effect. If you will see, if you will see, when we see that these groups, when attached to a conjugated system, when these groups are attached to a conjugated system, then the order of inductive effect is reversed. When these groups are attached to conjugated system, then order of inductive effect, yeah, or you may say order of donating electrons, order of donating electrons is reversed. It is reversed. First of all, we should know what's meant by a conjugated system. A conjugated system means alternate single and double bond, or a double bond followed by a single bond. Or rather, I may say in this way, this type of bonding: C, single bond C, double bond C. C, single bond C, double bonds. This type of system is called conjugated system. That means why there is a single bond followed by a double bond, or why a single bond is attached to a double bond. And you see, this is C double bond C. As we know, double bond is considered as a functional group. The carbon atom attached, the carbon atom attached to this doubly bonded carbon atom is called alpha carbon atom. This is called alpha carbon atom. So if there will be another carbon from this side, that will be again alpha carbon atom. So this hyperconjugation effect, it is observed in compounds like this, why there are different groups attached to this conjugated system. For example, if this C double bond C is having this carbon, it is having alpha hydrogens on this carbon atom. If there are alpha hydrogen atoms on this carbon atom, then in this way, suppose let me show here, this is C double bond C single bonds. If hydrogen atoms are attached to this carbon atom, this alpha carbon atom, due to this alpha carbon atom, first of all there should be conjugated system, and after if after having conjugated system, there should be alpha hydrogen atoms. Alpha hydrogen atoms are the atoms attached to alpha hydrogen atom, and these, what happens in this system, the electrons from this alpha hydrogen atom, they get displaced towards this conjugated system. With the result, this single bond, it acquires a little double bond character. So this shifting of electrons from alpha hydrogen system towards conjugated system, this effect is called as hyperconjugation. This is called as hyperconjugation. So hyperconjugation is actually the release of electrons from an alpha hydrogen atom towards the conjugated system, resulting in the shortening of bond length in the conjugated system. So what happens actually when this electron pair is shifted towards this conjugated system, this single bond acquires a little double bond character. When it acquires a double bond character, that means no bond is remains there actually between carbon and hydrogen. It seems as if there is no bond between carbon and hydrogen. And this way, you see, after displacement of electrons from this hydrocarbon hydrogen towards conjugated system, we will have now in this way C H H. There will be no bond between hydrogen and carbon because this electron pair has got shifted to this carbon, so it will be in this way. So this electron will shift when this electron pair between carbon and hydrogen is shifted towards this conjugated system. Then the double bond of the conjugated system is the electron pair of this double bond is shifted towards this carbon. So you will have C single bond C. Now there will be electron pair on this carbon, or you may say there will be negative charge on this carbon. So in here, when electron pair has got shifted towards this, that means a small positive charge will develop on hydrogen atom. There will be no bond, then there will be practically no bond between carbon and hydrogen. So this type of effect, where there seems no bond between carbon and hydrogen, this type of system, as I have told you, it's called a hyperconjugation system. And because of no bond between carbon and hydrogen, it is also called as no bond resonance. This phenomena is also called as no bond resonance. As this phenomena has been first of all observed by Baker and Nathan, so it's also called as Baker-Nathan effect. It is also called as Baker-Nathan effect. Baker-Nathan effect. Dear students, you are observing that on here in this compound, in this particular system, we are having three alpha hydrogen atoms. So release of electrons will take place through all these three hydrogens. That is one by one. First, this electron pair has got dislocated towards this position. Now this electron pair will locate. Then later on this electron pair will also dislocate. So in this way, in this type of compound, let me write here the compound CH3 single bond CH double bond CH2. Now see what will happen. This compound will obtain another structure when this electron pair is shifted towards this position and this gets shifted towards this position. So we will have CH2 H positive double bond CH single bond CH2, negative charge will develop on this carbon. So this structure has resulted due to release or displacement of electrons from this carbon hydrogen bond. Now suppose release of electrons takes place from this carbon, this hydrogen. This electron pair will be displaced towards this towards conjugate system. First of all, this electron pair between this carbon and hydrogen has shifted towards the conjugated system. Now let us shift or just locate this electron pair. So the next structure will be C H H H. There will be no bond between this carbon hydrogen now, and the remaining will remain same. It will become double bond CH, single bond CH2, and negative charge will develop on this hydrogen. Then if this electron pair is released towards the conjugated system, then the next structure will be CH H positive. There will be now no bond between this carbon and hydrogen, and it will become C double bond CH, single bond CH2. There will be negative charge on this carbon. So we observe that in case of this compound, if you see, it is propene 1, 2, and 3. In propene, because of this no bond resonance or because of hyperconjugation, we get three structures 1, 2, and 3. And these three structures are called as no bond resonance structure. No bond resonance structure. Now you see, in case of CH3 group, that is methyl group, in case of methyl group, there were three hydrogen atoms on carbon, on alpha carbon, that with the result, three new structures came into existence. These are actually a sort of resonance structures. This is why it is also called as no bond resonance, because when a compound is represented by more than one structures, those structures are called as resonance structures. So here we have three resonance structures, three no bond resonance structures, because of three hydrogen atoms on the alpha carbon atom. Now instead of CH3, if there will be ethyl group, that's in this way, CH double bond CH 2 single bond CH2 single bond CH3. If there will be this type of compound, you observe, in this type of compound, this is conjugated system, C single bond C double bond CH. This is conjugated system. To this conjugated system, this is alpha carbon, and on this alpha carbon you observe now there are only two hydrogen atoms, two alpha hydrogen atoms, and a methyl group. So this methyl group will not take part in no bond resonance. It will be only these two hydrogen atoms. So it should be kept in mind that hyperconjugation is involved, or hyperconjugation comes into existence only when there are alpha hydrogen atoms available. If there will be no alpha hydrogen atoms, then no hyperconjugation will take place. So the number of structures obtained will also depend upon the number of alpha hydrogen atoms. So this compound will now attain another structure CH3 C. You see, if this electron pair shifts here, then it will remain CH positive single bond CH. It will become double bond CH single bond CH2, and negative charge will develop on this carbon. So it is first resonance structure, no bond resonance structure. Now if release of this electron pair takes place towards the conjugated system, then the new structure will be CH3 CH H positive double bond CH single bond CH2. So this is second hyperconjugation structure. Now you observe that when there was methyl group attached to CH double bond CH2, then three resonance structures were formed. But when there is ethyl group, so in case of ethyl group we observe only two resonating structures are possible. Now if there will be isopropyl group CH3 CH CH3 attached to CH double bond CH2. Now you can observe by yourself that only one hydrogen is there, so only one hyperconjugation structure will be formed. The new structure will be CH3 CH3. It will be H positive. This electron pair when gets shifted here, it will become double bond CHD to CH double bond CH2. So this compound, it forms only one hyperconjugation structure. So as per the number of hyperconjugation structures are concerned, it determines the suitability of the compound. A compound having more resonance structures is said to be more suitable. So keeping this thing in mind, we observe that this compound, which was propene, since it is having three resonating structures, then this compound is 1, 2, 3, and 4. It is but 1-ene. In case of but 1-ene, only two resonance structures are formed. And then there is another compound 1, 2, 3, 4. It is a 3-methyl but 1-ene, and it only one resonance structure is formed. It is because there is only one alpha hydrogen atom. So it depends upon the number of hydrogen atoms how many resonating structures are formed. As there as the resonating structures is more is the stability of the compound. So we observe that methyl group, in other words, is more produce more hyperconjugation structures as it has three alpha hydrogen atoms. So this is why we say that CH3 group is having more hyperconjugation effect than ethyl group CH3CH2, which in turn is having more effect than CH3 whole twice CH, which is more C than CH3 whole thrice C. Here there will be no alpha hydrogen atom. There will be only one alpha hydrogen atom, as you have seen here. There are two and there are three when they are attached to the conjugated system. This is why this inductive effect, as I have told you in the beginning, is reversed in case of these compounds. So this is hyperconjugation effect. It is the release of electrons towards conjugated system by the alpha hydrogen atoms or by the hydrogen atoms present on the alpha carbon atom. If the number of alpha carbon atoms is more, then the number of hyperconjugation structures will be also more, or it will be maximum, and with the result the suitability of the compound will get increased due to this hyperconjugation effect. This hyperconjugation effect is involved, or it decides, or it explains rather, so many phenomena in organic chemistry. So it has much significance in organic chemistry. So let us discuss a few significances of hyperconjugation. Significance of hyperconjugation. Its first significance is that it explains the directive influence of alkyl group. Directive influence, DIREC. Directive influence of alkyl groups. So what is meant by directive influence? What is meant by directive influence? Dear students, you see, in case of compounds having a benzene ring in them, suppose it's a benzene ring, and if to this benzene ring there are attached some substituents. For example, there can be alkyl group attached to the substituent methyl in this benzene ring, methyl group. Then there can be another substituent. Suppose there can be Cl group attached to this benzene ring. There can be another substance OH group attached to this benzene ring. So these compounds which have benzene rings in them, these compounds go a special type of reaction. Those reactions are called as electrophilic substitution reactions. They undergo generally electrophilic substitution reactions. So when this methyl group, it undergoes, or any compound containing benzene ring undergoes electrophilic substitution reaction, then the electrophile enters into the benzene ring. There are so many positions available for the electrophile to get attached to. Suppose this is this carbon where the substituent is already present. It is carbon number 1. It will be termed as carbon number 1. So if we will number this benzene ring from this side, it will be number 2. This is carbon number 3. This is carbon number 4. This is 5. This is 6. Same is the case here. 1, 2, 3, 4, 5, and 6. In the same way, this is carbon number 1. This is 2. This is 3. This is 4. This is 5. This is 6. It means that there are 5 positions available to us because position number 1 has already been occupied. So there are 5 positions available for the incoming group where it can get attached. Generally, in case of electrophile reactions, as I have told you, when an electrophile like halogen atom, chlorinium ion, Cl positive ion that acts as an electrophile, or nitro group, or sulfonium group. These are electrophiles. When they come to get attached into the benzene ring, where they will get attached, that will depend upon the group already present in the benzene ring. That is, here it is methyl group. Where the incoming group will go, that will be decided. That will be decided the group which is already present in the benzene ring. Suppose here it is methyl group, we will which will decide the position of incoming group. Here it is chlorine which will decide the position of incoming group. Here it is OH group which will decide the position of incoming group. Let me tell you in simple way. In case of this compound methyl group, the incoming group is, it goes to this position, position number 2. Position number 2. Here it is, suppose it is chlorine, it will go to this position, position number 2. And it also goes to position number 4. To position number 4. That means in case of when methyl group is attached to the benzene ring, you will get two products. One in which incoming groups attached to position number 2, and another in which the incoming group is attached to position number 4. This position 2 is called the ortho position, and position 4 is called as para position. So we say that methyl benzene, it gives ortho and para products. That means incoming group goes to ortho position and para position. And in case of chlorine, when chlorine is attached to the benzene ring, here once again same product is formed. That means incoming group goes to ortho position, and it can also go to para position, but it goes to para position as well. Ortho position as well as para position. As per OH group is concerned, in case of OH group, or let me take it COOH group. In case of COOH group, what happens? The incoming group doesn't go to position number 2 or position number 4, but instead it goes to position number 3. That means only one product is obtained when COOH group is attached. This position number 3 is called as meta position. So this is meta position, meta product. Here position 2 is ortho product, position 4 is para product. Here again, this is ortho product, this is para product. So the hyperconjugation effect, it explains us why this methyl group is directing the incoming group to ortho position and para position. That is why we get ortho products as well as para products in case of methyl benzenes. Why don't we get meta products? This phenomena is explained on the basis of hyperconjugation. Let me give it a little detail of it here. You see, this is methyl group attached to benzene. You know, this is carbon here. This is, so if you observe, it becomes a conjugated system. C, single bond C, double bond C. Once again, you see, C, single bond C, double bond C. So what has happened? In conjugated system, this is, since this is double bond, the carbon attached to double bond is alpha carbon, and hydrogen attached to it are alpha hydrogen. So what will happen? This electron pair will get shifted to this position. So you will get another structure of this methyl benzene. Remember, this methyl benzene is also called as toluene. So you will get a structure of this type. Now there will be no bond between carbon and hydrogen, and this bond, it will acquire double bond character because this electron pair has got shifted to this position. So this electron will get shifted to this position. So it will be electron pair at this position. These two electron pairs will remain at their own side. Later on, what will happen? This electron pair will go to this position. This electron pair will go to this position, and you will get one more structure. It will be like this. This is in the same. There will be no change in the structure here. It is as such for the time being. So what will happen? What has happened? This electron pair has come to this position, so it becomes double bond. This electron pair has come to this position, so it becomes a lone pair with negative charge. This electron pair remains at its own position. What will happen now? Now this electron pair will shift to this position, and this electron pair will come to this position. You will get one more structure. It will be C, H, H. Here it is no bond. It is double bond here. this electron pair has got shift here, it becomes double bond. This electron pair has got shift here, it becomes single bond. So and this electron, this electron pair will shift here and it will shift here. You will get one more structure. So in this way, by one hydrogen atom has given rise to three more structures in case of this compound toluene. Now you can see another three structures will be formed when this electron pair will get shifted to this position. Then three more structures when this electron pair will get shifted to this position. But you will observe in all these structures, the electron pairs which get shifted, it increases the electron density at this carbon. It's carbon number 2. And electron density is increased on carbon number 4. Electron density is increased on carbon number 6. But this carbon number 6, it's again carbon number 2 if numbering is done from this side. It is 1 and 2. So this position and this position, they are the same positions. So it is ortho position. This again ortho position. This is para position. Now you see, when an electrophile will come to attack this compound, you know electrophile has an affinity for electrons. So that electrophile will get attached either to this ortho position, or it will get attached to this para position, because we know that electrophiles have affinity for electrons. And here in case of methyl benzene or toluene, these electron pairs are available on ortho and para positions. It is because of the no bond resonance. So the products obtained will be ortho products and para products. So with the help of this hyperconjugation, we are able to explain the direct influence of alkyl groups in case of benzenes. So for today, it is sufficient. Inshallah, tomorrow we will discuss some other relative effects or significances of hyperconjugation effect. Then we will move forward, inshallah. Thank you very much.